Okay, so hello. So today we'll learn like how to calculate torque on a system or for a system. So what is basically torque? Like force is responsible for translation motion, torque is responsible for rotational motion. So how will we calculate torque on a system? Okay, so let us understand how will we calculate torque. Suppose that we have a system like this as shown in figure. Suppose we have a system like this. Suppose this distance is L and this force is given to be F. And suppose this angle is given to be theta. Now, how to calculate torque? So to calculate torque, there are different ways. So I'll discuss all the ways today. So torque is basically R, F, sine, theta. Now, what do we mean by R? So R is basically the distance between the point about which the body will rotate. So this point and the point on which we are applying force. So R will be L. How much force is there? The force is F. And now how to calculate sine theta? So what you have to do is you have to extend this line, the line joining the point about which the body will rotate and the point where the force is applied. And this angle will be your theta angle. So if we'll see, this angle is theta only because this theta and this theta will be equal. So the torque will be LF sine theta. So this is how you have to calculate torque on a body. Let's take some more examples now. Suppose in this case, suppose this distance is given to be L by 2, this force is F, and suppose the body will rotate about this point. So my question is, what will be the torque on this body? So first you have to use this formula, that is RF sine theta. Now first calculate R. R is the distance between the point about which the body will rotate and the point on which the force is being applied. So if we will see, this distance is L by 2. So this is L by 2. How much force is there? The force is F. Now how to calculate sine theta? So what you have to do is you have to extend this line. And what is the angle between this line? So it's 90 degree. And sine 90 is what? Sine 90 is 1. So torque is L by 2F. Okay, let's take one more example. Suppose that now the force is F and it is being applied here at distance L from the center. Center means the point about which the body will rotate. Now we'll calculate torque. So torque will be R F sine theta. Now what will be R? R is the distance between the point about which the body will rotate and the point at which the force is being applied. So R is L. What is the force? The force is F. Now how to calculate sine theta? Simple. You just join both the points, the point about which the body will rotate and the point at which the force is applied, and you extend it. So basically this is R, this is F, and the angle between them is 0 degree. So sine 0 is 0, so torque will be equal to 0. So always remember, to calculate torque, the theta is calculated like this. But there's a trick here. The trick is that in this question, if you'll see, it was a road and the force was like this. So if I'll extend the force, if you'll see, if I'll extend the force will pass through this point only. So if the force passes through the point about which the body will rotate, then torque of that force will be equal to 0. I'll discuss this in another example. So let us come to that example now. Suppose that this is a disk and there are two forces, F1 and F2. Now let's calculate torque of both these forces. For F1, you will see, if I'll extend the force, it will pass through the point of rotation. The torque of this force will be equal to 0. It's very easy, very simple. Now let's calculate the torque due to F2. Now let's join first this line. So this will be radius. So torque will be R F sine theta. So R will be capital R because the R is the distance between the point about which the body will rotate and the point where the force is being applied. The force is F2. Now how to calculate sine theta? You just extend this line and this will be your theta 90 and sine 90 will be 1. So there will be only one torque, that will be RF2. And if you will see, this body will rotate in clockwise direction. So the torque will be minus k cap. Please remember, if the body or the torque is in clockwise direction, the direction to be put is minus k cap. If the rotation is in anti-clockwise direction, then the direction will be positive k cap. In this case, if you will see, this force will rotate the body in clockwise direction. So minus k cap. Let's take one more example. Suppose that I have a force F1 applied like this. Suppose this angle is theta and this distance is given to be r by 2. And suppose one force F2 is applied like this. Suppose this distance is r by 2 and suppose this angle is given to be theta. Now I have to calculate, suppose this is theta 1, theta 2, torque due to both the forces. Now let's see how will we calculate torque. So torque due to F1. So the first put the formula R F sine theta. Now what will be R? R is the distance between the point about which the body will rotate and the point where the force is applied. So R will be R by 2. F is force, the force is F1. Now let's calculate theta. So what you have to do is you have to just extend this line and you want this angle. So this is theta 1. So that will be 90 minus theta 1. So sine 90 minus theta 1. So the torque will be R by 2 F1 cos theta 1. And the torque will be clockwise. If you'll see, this force will try to rotate the body in clockwise direction. Now let's calculate for F2. So torque 2 will be, first put the formula RF sine theta. So R is basically R by 2 only because the point where the force is applied is as at R by 2 distance from center. Force is F2. Now let's calculate theta. So if you will extend this line, the angle between this line and force is theta 2. So we have the angle directly. So torque will be R by 2 F2 sine theta. So if you will see, this force will rotate the body in anti-clockwise direction. If you have any confusion, what you do is the arrow of F2 is in this direction. So you just draw it like this. So it will be anti-clockwise. If you want to know how will F1 rotate, so the direction of F1 is like this. So you have to do what you do is you just draw it like this. So this is basically clockwise and this will be anti-clockwise. So this will be minus k cap. This will be plus k cap. Now you can add both of them. So one of them will, subtract the another one. The more will be subtract the lesser one. Okay. Now let's take one more example. Suppose the force is applied like this and this angle is given to you. Suppose this angle is theta. Now what you do is just join this. So this distance will be r. So torque will be r f sine theta. So what will be r? What will be f? And how to calculate theta? You just extend this line. So the angle between r and f is theta. So the torque will be rf sine theta. And how it will rotate? The arrow is in this direction. So you have to join in this direction. See, both the arrow are in this direction. So this will be clockwise, anti-clockwise torque. So direction will be k cap. So this is how you have to calculate torque on a system. Now let's come to the last example now. Suppose this is a road whose mass is m. So mg will act downwards. Suppose normal is like this n1, n2 is in upward direction, and friction is in this direction. Suppose the body is not rotating. On this side, suppose the wall is smooth, so there is no friction. And on the bottom side, the wall is not smooth, so friction will be there. Now, if I'll say the body is in equilibrium, so it means net force will be 0. And if I say the body is in rotational equilibrium, so for rotational equilibrium, net torque will be 0. So first draw the free body diagram. So if we'll join, then mg will be downwards and n2 will be upwards, n1 will be in forward direction, friction will be in backward direction. So since the body is in equilibrium, so n2 will definitely equal to mg and n1 will be equal to f. So the body is in translational equilibrium because all the forces are cancelling each other. But now I want to see what will be the value of forces if the body is in rotational equilibrium also. So for rotational equilibrium, there will be no torque. So what you have to do is you have to calculate the total torque and put it equal to 0. So you can calculate torque about any point because the body is in equilibrium. So let's calculate torque about the bottom point. Suppose this point A. Suppose let's calculate torque about this point A. So if you will see N2 is passing through A, so torque of N2 will be 0. F is passing through A, so torque of small f will be 0. And let's calculate torque of mg. Now suppose this angle is theta. This distance is L by 2. So how to calculate torque due to mg? So formula of torque is R F sine theta. So R will be L by 2, force will be mg. Now let's calculate the value of theta. So what you have to do is you just extend this line. So R will be in this direction, mg is in this direction. So this angle we want. So what will be this angle? So this is theta. This is 90. This will be what? 90 minus theta. And this will be what? 90 plus theta. So sine 90 plus theta will be cos theta. So this is torque due to mg. So you have to calculate the angle between R and F. So how will you get the R? You have to extend this line, the line which is joining the point about which you are calculating torque and the point of force. So angle will be 90 plus theta. So L by 2 mg cos theta. Now let's calculate torque due to N1. So N1 is being applied at this point. So the distance of this point from A will be L. So on the place of R, I'll put L. On the place of F, I'll put N1. And how will we find sine theta? So just extend this line. So this will be your theta. Now this is theta, then this will be also theta. So this will be pi minus theta. And sine pi minus theta is sine theta only. So basically, we have the two torque. But since the body is in equilibrium, so you can equal two torque because they both will be cancelling each other because net torque is 0. So L N1 sine theta. So L and L will cancel out. And you can see the N1 will be equal to mg by 2 cos theta upon sine theta will be cot theta. So this is how you have to calculate torque when the body is in rotational equilibrium. Because in rotational equilibrium, the net torque is equal to 0. So you can calculate torque about any point and put it equal to 0. So about point O, the torque of mg will be, in anti-clockwise direction and the torque of N1 will be in clockwise direction. So both will cancel each other and net torque will be equal to 0.